Static electricity is cool, but what about the electricity that powers our homes? That's current electricity. This type of electricity is all about electrons flowing in a continuous loop. Think of it like a river, but instead of water, it's electrons moving along a path. This flow of electrons is what powers our lights, appliances, and gadgets. Fun fact, a single lightning bolt can carry enough electricity to power 100,000 homes for an entire day. For electricity to flow, it needs a path, just like cars need roads. Imagine a bustling highway filled with cars zooming to their destinations. Similarly, electricity needs a well-defined path to travel from one point to another. Without this path, the flow of electricity would be chaotic and inefficient. This path is called a circuit. Just as roads connect different places, circuits connect different components in an electrical system. They provide a route for electricity to travel, ensuring that it reaches its intended destination without any interruptions. A simple circuit has three main parts: a power source, like a battery, wires, and a load, something that uses electricity like a light bulb. The power source provides the necessary energy to push the electrons through the circuit. The wires act as the pathways, guiding the electrons to their destination. The load is the component that uses the electricity to perform a specific function, such as lighting up a bulb or powering a motor. The battery pushes the electrons through the wires, which act like tiny highways. These electrons are like tiny cars, traveling along the wires to reach their destination. The movement of electrons through the circuit is what allows electrical devices to function. When the electrons reach the light bulb, they give off energy in the form of light and heat. This is because the electrons transfer their energy to the filament inside the bulb, causing it to glow brightly. The heat generated is a byproduct of this energy transfer. Fun fact, the world's largest circuit is the power grid, which connects millions of homes and businesses. This vast network of wires and power stations ensures that electricity is available whenever and wherever it is needed. The power grid is a marvel of modern engineering, enabling us to enjoy the conveniences of electricity in our daily lives. From lighting up our homes to powering our devices, the power grid plays a crucial role in our modern world. Some materials let electricity flow through them easily. These materials are essential in our daily lives, powering everything from our homes to our gadgets. We call these materials conductors. Conductors are crucial because they allow the smooth passage of electrical current, making them indispensable in electrical circuits. Metals like copper and aluminum are great conductors. Copper in particular is highly valued for its excellent conductivity and flexibility, making it a top choice for electrical wiring. That's why we use them for wires. These metals ensure that electricity can travel efficiently from power sources to our appliances, lighting up our homes and powering our devices. Other materials, called insulators, resist the flow of electricity. Insulators are just as important as conductors because they provide safety and control in electrical systems. Rubber, glass, and plastic are good insulators. These materials are used to coat or encase electrical wires, preventing accidental contact and ensuring that electricity flows only where it is intended. They keep electricity from flowing where we don't want it to, like through our bodies. This is why electricians wear rubber gloves and use tools with insulated handles to protect themselves from electric shocks. Fun fact, did you know water is a good conductor of electricity? This is because water often contains dissolved salts and minerals that can carry an electric charge. That's why it's important to stay away from electrical appliances when your hands are wet. Wet hands can increase the risk of electric shock, making it crucial to always dry your hands thoroughly before handling any electrical devices. Remember, safety first. Have you ever played with magnets? They have an invisible force that can attract or repel other magnets. This force is called magnetism. Magnets have two poles, a north pole and a south pole. Opposite poles attract while like poles repel. This means a north pole will attract a south pole, but two north poles will push each other away. Fun fact, the Earth is a giant magnet. It has a magnetic field that protects us from harmful radiation from the sun. Electricity and magnetism might seem different, but they are actually closely related. When electricity flows through a wire, it creates a magnetic field around the wire. This is called electromagnetism. We can use electromagnetism to create powerful magnets, like the ones used in MRI machines and electric motors. Fun fact, did you know that electromagnetism is used to levitate high-speed trains? These trains can travel very fast because there's no friction from wheels on tracks. Electricity powers so many things in our homes. When we flip a light switch, electricity flows through wires to the light bulb, making it light up. Our refrigerators use electricity to keep our food cold, and our ovens use it to cook our food. Electricity also powers our televisions, computers, and video games. Fun fact, the average home uses about 900 kilowatt hours of electricity per month. That's enough to power a 100-watt light bulb for 900 hours. Section 8. Electricity at school powering our learning. Electricity is essential at school too. It powers the lights in our classrooms, the computers in the library, and the projectors we use for presentations. Many schools also have interactive whiteboards and tablets that rely on electricity to work. Fun fact, the first school to use electric lights was in Ansonia, Connecticut in 1880. Before that, schools used candles or gas lamps for light. Section 9. Electricity and transportation. From cars to trains. Electricity is changing the way we get around. Electric cars are becoming increasingly popular because they are better for the environment than gas-powered cars. Trains, subways, and even some buses also use electricity to move people quickly and efficiently. Fun fact, the world's first electric car was invented way back in 1837. It was much slower and less powerful than today's electric cars, but it paved the way for the future of transportation. Section 10. Electricity and communications staying connected. Can you imagine a world without phones, computers, or the internet? Electricity makes all of these forms of communication possible. Electricity carries signals through wires and satellites, allowing us to talk to people all over the world instantly. Fun fact, the first transatlantic telegraph cable, which used electricity to send messages across the ocean, was completed in 1858. Section 11. Fun with electricity safety first. Electricity is amazing, but it's important to remember that it can also be dangerous. Never stick your fingers or objects into electrical outlets or play with electrical cords. Always ask an adult for help if you need to use anything that plugs into an outlet. Stay safe and keep exploring the electrifying world of science. Fun fact, our bodies use electricity too. Our brains send electrical signals to our muscles telling them when to move.